Alright, so begins another draft physics video presentation. Mostly comments, I guess. But obviously we'll get into other subjects, or all the subjects, or the general subject of trying to analyze why do you believe what you believe. See, there's no real explanation. I'm not getting back much feedback according to like how you prioritize and logically rank different theories or ideas and how you analyze them. What kind of standards do you apply? See, a lot of people think that people acquire their belief system in some sort of similar way, and apparently people don't. I mean, some people require the theory, okay, to be defendable in the sense that you can explain to even somebody who doesn't want to hear it why it's the truth, why they should believe it, because it's, and you have enough evidence to do that. And I'd say the theory of evolution, there's really strong evidence. All the non-believers are non-believers because they really haven't looked at the evidence, and that there might be a few who are just so compelled by the lie that, well, human beings need religion, and so they don't really believe there's a God. They don't really believe in any of the story. They just believe that people need religion, or somehow they turn into assholes. Which I suppose is some threat, but it's not nearly as big a threat as the asshole you turn into when you're a religious kook. Because those assholes torture people for no good reason. They have some notion that every fetus is precious, and it's just silly things that don't make any sense at all. Fully sentient mammals don't mean anything, but somehow the unconscious, barely formed fetus is special. It needs special consideration. Idiotic things like that are the byproduct of that kind of crap. Well, anyway. Yeah. So, I'm sitting here from a perspective where I'm just kind of honestly stating that, yeah, I was kind of a person you had to sort of prove something to me. I needed evidence. I wasn't the kind of person who just believes because they say so. So you have to go look at it and pick at it and find out whether there's any reason to believe it. And I was kind of interested in having the right answer because I sort of had some innate perception that right answers are better than wrong answers. That you're really not empowered by having wrong ideas unless the idea is for you to do something ludicrous like, jump on a grenade or something. That somehow the basic mechanism relies on for you to do something not just in your own interest, but in, the right answer. It's what you want, and you want to do it for the right reason. So, yeah, you can get somebody. I guess the point I'm making is you can get somebody to jump on a grenade for a dumb reason. But if you're going to jump on a grenade, you want to do it for the right reason, is sort of the argument. And so, yeah, I'm that kind of person. I want to do the right thing for the right reason. And, that's... I don't want to be stooped, and I don't want to be fooled, and I want to be shenaniganed, and I want to be tricked out of getting it right and living the best way I can. I don't even know if it applies to living so much as it just applies to thinking. I don't want my brain to be wasting its time chasing illusions and delusions and crap that is not have anything to do with the reality that we actually live in. And I guess underneath that, as an assumption, is something like, yeah, there's only one reality we live in. There's only one right story, correct description. And, you can say something that's mostly true. This piece of chalk is white. That's a good enough statement. Now, somebody could pick it apart and say, well, it's really gray. It's not really white. Or some kind of crap like that. They could get into a semantics argument. But for the sake of making a distinction between, it's certainly not this blue thing, Um, and yes, you could make some comparison where you could make the chalk look blue, but I'm just saying, again, without semantics rubbish, um, there's statements you can make. And yes, there's a perfect way to describe its color, where you use a lot more words and well, I'm not talking about compared to a grayer gray, it's blue if I compare it to something grayer or some kind of idiotic thing like that. But you don't want to have to make all your statements in life disqualifying all the perversions of your statement, which some people want to play those games and, contend that they've defeated your argument because they've used semantics. And so a lot of people do that against conventional physics. They could say a lot of dissidents are fairly lazy and all they're doing is taking some explicit statement and trying to point out how that explicit statement can't be true as stated. It's not perfectly stated, and therefore they can pick at it. Now, I would argue I'm really not interested in those kind of victories. And there's like I said, everybody has to make their own judgment about what people are doing when they're attacking something, if they're attacking it from some position of credibility, or whether they're just attacking because that's all they know how to do. They don't have anything else. Well, anyway, so enough contextual blah, and on to the fun. All right, is it possible to volume up on your end? I mean, it's so, by comparison, these videos are averagely loud. So they're not unaveragely loud. Yeah, so as long as I'm compliant with the average, I'm saying I'm winning. All right, so that's my standard. There's a ton of videos that are a lot less volume than my videos. Now, maybe that's not true for music videos and anime videos or whatever you're used to watching. But for most conversational videos, it's loud enough. So, whatever. So it gets 5 thumbs up for that. And I'm just saying, I can point you to a ton of videos where nobody's nagging about the volume being too low, and they have half the volume of these videos. I mean, half. Now, yeah, there is a possibility I can do it, but, the quality of the sound deteriorates as I attempt to do that. So I don't know if that's worth anything, or worth enough. But whatever. And then some fat bastard person talks about their poo. The typical troll. So let's understand. I mean, it's not a huge thing for you to understand, but I'm obviously winning this argument, right? I mean, fat bastard is really... maybe secretly he is a friend of mine, and he's just trying to make me look really good by behaving really badly. So he's doing the anti thing, like he's showing how lame their argument is. All they can do is talk about their poo as a response to my physics. So like he's just proving, oh, look how lame they are. They can't make a single friggin' argument. I mean, they can't show a piece of evidence. They can't do anything. All they can do is talk about their poo as a counter argument. I mean, it does make me look awful brilliant by comparison, right? So he's probably a setup of mine, right? He's one of my best friends, and he's just trying to show how lame the counter argument is. I mean, it really is pathetic. Pathetic. Okay, and I mean, a word I use too often, but it is pathetic. Alright, now let's see if this is a real comment of some kind. Let's see. Oh dear, multivitamin. Do you take a multivitamin or supplement for brain health? If they had any evidence of any of this crap meaning anything, I'd say sure. But, frankly, none of it's, there isn't too much like, well, you need water every day and you need a certain number of calories. But beyond that, they really haven't proven anything. With like what you would consider to be some sort of evidence. And it seems like they should be able to find the evidence somewhere. They should be able to give the stuff for 10 months to 10 people and say, look how much better they are than they were. Look, this is the before picture, this is the after picture. Something that's not obviously crap. And you really don't see any of that. So, blah, 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 blah. such as omega-3 and B12, among other things. Well, you sort of need B12 anyway. I don't take it as often as I should. Being a vegan, you probably should eat some bacteria now and then. Lick some dirt off the sidewalk or something, just for your health. Because in nature, of course, we ate a lot of crap with our food. See, that's why our body doesn't make B12, is because bacteria excrete it, and it's on the surface of everything. And so, if you were living in, even if we were living in log cabins, we'd be ingesting it all the time. Wooden everything, wooden cutting boards, lots of places to get it. And so in the modern era, it's a little more rare, just because we wash our hands and we do things that are, that wipe out all the B12. But anyway, not a big deal, frankly. I seem to be getting along. I mean, I can't say that I don't need any. A little B12 shot now and then is really nice if you have any kind of healthcare coverage, but whatever. Can't afford that kind of thing. I often feel like I don't get enough because my diet is really terrible and unvaried. Yeah, well, I don't know if varied makes any damn difference at all. Gorillas eat the same thing every day forever. Yes, seasonally they get a little boost here and there, because of some fruit that goes ripe. But really doesn't make a difference. Your body's made to, it's a garbage disposer. You just garbage in and obviously garbage out. And it's going to get what it needs. It really just wants the calories. I mean, most of the other stuff, you're just going to get it whether you like it or not. You're going to, enough of it to glean. And so I'm not against, you want to take vitamins, I'm certainly not against it. I'm just saying a lot of it is just people figuring out that they can make a living selling this crap to people because it's like hope. It's like, here, this will make things all better. And it really won't change anything. But anyway, was wondering what your thoughts are on this. Yeah, so my thoughts is I just don't think it really matters. I have I've had a very unvaried diet my whole life. My parents had a very varied diet. They ate meat and all the crap and, crap. I mean, they ate vegetables and stuff, but I just mean every meal was some sort of meal with a whole bunch of crap in it. And, they lived to be in their 90s, so obviously it's not going to kill you, but necessarily. I'm just saying that it's just calories. And it's the kind of food you mix, If you don't want to get fat, then you have to, and you want to still eat a lot of calories, well, then you have to mix your calories. That is, you have to have fat calories with protein calories with carbohydrate calories, so they go through you faster. If you eat just carbohydrates, you have to be smart enough to know, well, I'm going to get everything I eat. I'm going to get most of it out, right? I'm going to get 80% of the calories or 70%. See, if you eat a varied diet, then you get less. Your body sort of says, I don't like some of this crap you ate, so I'm going to get rid of it. And by getting rid of it, it gets rid of the other stuff too before it really digests it. So it just depends on how you think your body should be working and what it's gleaning out of the food it's eating. So it's all this metabolism stuff. You have to understand how your metabolism works in terms of why it goes fast or why it goes slow, and understand how many calories you're eating, and that, they should have stuff in them. They should be made out of something other than plastic. Something you can actually digest and actually get value out. So, but basically your body's going to break it all down into kind of simple little tiny molecules. Like most proteins can't pass through your intestines, so you can't eat a protein and get a protein. You're getting the amino acids or the things even smaller than that. So your body breaks down everything and remakes it, essentially. Mostly. Alright, anyway. According to calculations, you are 100% correct. His brain is severely lacking in necessary vitamins for people functioning. So this is HAL 9000, troll. And of course, the guy decided to respond to the troll, which is, just probably not a good idea. It was a question on whether he does take supplements, not because I think his brain is lacking. Quite the opposite, actually. It doesn't really matter. I mean, I'm arguing physics, I'm not giving healthcare advice and all that kind of crap, but whatever. Lifestyle advice, I don't know. I mean, I suppose I could, but it just doesn't seem like really my project. I don't want to really make a separate channel to, go over the basics, But that's all I would say is proven, is the basics. The basic idea is, I mean, we really didn't evolve to have vitamin deficiencies, so we did evolve to be able to make the most out of the least. So kind of like crocodiles. So we're not nearly as efficient as them. They can eat anything, once a month and do just fine. But anyway, they don't have to build civilizations and stuff. They can just lie around, wait for their next meal, just reduce their production of energy, their use of it, and and therefore just get by on one meal a month. Anyway, doesn't matter. All right, so HAL, we really don't need HAL. Just an FYI, but I've run a simulation in my mind in Gary's model, and it doesn't work. Yeah, right. It's a great counter argument, HAL. You've specifically laid out all the flaws and the but no, you really haven't. There's a friction problem. No, there really isn't. It's already been explained. And the entire theory is a failure. Yeah, well, you didn't demonstrate that with a single, like I said, you didn't point to a single experiment. You didn't point to a single articulated fact. Nothing. You're just, citing nonsense. So you're a really shitty computer. You don't have any database of facts and figures. You just, spout crap. So again, you're just making me look better though, Hal. So thanks. Appreciate it. Appreciate your effort to make me the winner by being such lousy competition. I mean, I couldn't possibly lose the race because, you're running backwards, fella. All right. Moving on. Okay. What a load of horse shite. So we can't even say shit. But anyway, again, this is from somebody called Star Child. So what's your delusion of you're magical? You have superpowers. If you landed on some other planet, you would have been Superman, but this planet just happens to not, has too much kryptonite in the soil, and so therefore you can't be Superman here or something to prove that you're a star child. I mean, yeah, you're just so brilliant, are you? No, you're just crocodile, okay, with a different configuration of crocodile, but you're just crocodile. You're a scheming, what's in it for me, ego-centric little douche, with perhaps even a micro penis. You're not some magical product of the universe. You're a really crappy robot that has a delusion. I'm a star child. I'm a star child. Bink, 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 bink. Star child. You're like that stupid. Oh, remember that there was that TV show like Buck Rogers or something? They had that really bizarrely faggoty robot Winky or something, Blinky. Oh God, that was so gay. Anyway, that's you. You're pathetic. Using the word pathetic. But you have to make some kind of argument. I mean, you're just so weak. It's just so pathetically weak. I mean, you're getting into the boxing ring and you just wet your pants. Okay, that's all you did. You just wet them. And that's your big threat. I might step in his stupid piss. I mean, that's the only way you're scaring anybody with your you know your brilliance is, oh, I might step in some of the excretions this loser is, you know, dropping on the floor. Ugh, pathetic. All right, onward we go. You commenters suck, by the way, just to let you know. Anyway, I'm not sure if you've talked about this before. I'm sure I have. As I don't catch all your videos. Well, you don't, whatever. You go to the playlists, subjects. But I really think you should write a book. Yes, I have covered the subject. Why? Most people don't read books, And frankly, what's the difference? I mean, explaining with drawings, I think, is pretty good. Okay, it's a little less perfect. A book requires you to really try to make it much more concise. And I'm clearly not against doing that. I'm just saying it's really time consuming when you're doing a technical subject and you can't just... I mean, I'm currently found an audio book copy of Hawking's book. And so far, I'm a quarter of the way through it. And it's just a regurgitation of a history all the physicists already know. And it's just so rudimentary and so nothing so far. And again, it really doesn't get to any of the challenging questions. It just says, we decided in 1801 that light's a wave, and we proved it, and so that's done, that subject. That kind of crap. It doesn't go into any of the details about the integrity of the experiments or how much they're proven. Like even the bending of light, they just say it. Oh yeah, light's, Einstein proved light is bent by gravity or something. No, he didn't. The proof really sucks. So I'm just saying it's, books aren't worth much. And again, the channel sort of is an honest description. DraftScience is how I started. All of it isn't all tied up in perfect little knots, and so I'm not ready for a book. I suppose it would be one argument. I mean, the book on magnetism could be written, and the book on, I think, photons. So, I mean, these are specific papers I probably should write. Okay, is this new description of what a photon is that I think explains all the polarization effects, explains a lot of things. So I think that's valuable. The gravity theory, and the theory of charge and magnetism, the monopole argument, those are all arguments that can really be made. But again, tying the whole thing, putting it all in one huge giant package, all done, 2 + 2 + 2 physics, is pretty simple. There's just a few little bits that I got to finish. Once the simulation is completed, I think the story is everything's going to start falling into place, because it'll be understood that the simple rules do dictate the more complex effects, and it's just the fact that you're increasing the amount of things interacting and therefore increasing the likelihood of all these improbable events taking place that lead to arrangement and complexity. So, all right, thanks for the nag, I guess I'll say. All right. It's probably something I should do. I'm just saying, for the sake of these arguments, I shouldn't have to write a book to get a coherent response from conventional physics. I mean, they should be willing to be challenged, and so far they're not. I mean, I'm still, if any of you know a named physicist or have any connection to one that has some sort of integrity to put on the line, I'm willing to pay thousands of dollars, to interrogate them. I'll pay real money to talk to somebody who has some sort of exposure, somebody whom I can glean some sort of benefit out of beating the crap out of. Because there's nothing I want more than the opportunity to beat the crap out of. I'm sitting here in the ring saying, come on, I'll pay you to come into the ring because I am going to beat the shit out of you. Okay, you are going to lose. and I'm going to win. And that's the whole game here, is to prove something. And I'm ready to prove it by having the direct interaction, just to point out how weakly evidenced their whole pile of crap is, and to explain how the contradictions are all over the place. The theory really doesn't work. It really is incoherent. Bent space, virtual photons, these are the main players in their wooey-verse. Okay, some notion that nothing is bent, and therefore the somethings are saying, oh God, the nothing is bent. I must do something because the nothing is bent. I mean, it's a ludicrous foundation. And again, their evidence for everything they claim to be well-established fact is rubbish. It's crap. They never repeated the Eddington experiment. Let's say it again. Thousands of satellites in space, and not one of them directed to do this most important experiment. This experiment that made Einstein credible. And it's never been repeated. Because it was a piece of crap as an experiment, and the results were inaccurate, and therefore they have a completely wrong understanding of how the universe actually works. I mean, you go on and on. The whole redshift nonsense as being an excuse to create an expanding universe. I mean, it's all a nonsense. All right, anyway. But I really think you should write a book. Just a downloadable PDF would be fine to start with. I know you have some quick write-ups on your ideas on your website. Yes, the basic theme is there. The picture of the magnet, working the right way. I got to fix the description a little bit, but the idea that there's a force coming from the outside that the magnet is filtering is there. It's there to be challenged, and no one's challenging it with any kind of argument, with any kind of demonstration how that can't be true. Here's an experiment that demonstrates that can't be the right answer. No, it fits all the evidence. All right, but books are important. It says you, again, to the dissemination of ideas. I really don't think so. If you're saying that physicists have to read books and they can't watch lectures and they can't watch somebody making an argument, I'd say that's kind of silly. Anyway, and for posterity as well. A book is a coward's way, right? I mean, it's completely without any feedback. You can't ridicule it. You can't point out anything. You can't say, stop writing there. That's complete bullshit what you just said. I mean, it's, these are supposed to be people who understand, well, number one, you're supposed to have some knowledge of communication if you're writing a book, but you're attempting communication. But you would think that they would have the obviously gravitate towards this medium where you can do this feedback thing, where you can interact and you can explain and you can draw and you can do you can add lots of value to the book. You can correct it. Like the next time I explain it, I'll draw the circle a little rounder so they get the idea or something. You can fix your book as you go. I mean, I just think it's such a more superior way to communicate than reading books. But whatever, you say the scientists can't do better. All right, I say I think they can. I think they choose not to because they're afraid of the interaction, frankly. The playlist outlining the important elements probably communicates and illustrates the mechanism effectively. Yes, true enough. And these videos, I think, do it. There's also a website. If you check the video description, you can find useful links there. Yes, the playlists especially. All right, anyway. So I don't know what this stuff is. I don't know what this wavy thing, starry thing, wavy thing. What the hell is that? I don't know what the hell that is. People have been doing that at me for like 10 years. I don't know what the fuck that means. What is it, little birdie? Wait, what is that? What the fuck does that mean? And then they do this hashtag crap. What is this? What is this? It's not Twitter. Newsflash. It's called YouTube. It's not fucking Twitter. Jeez. Looking good, Gary. Well, I don't know. At number sign, whatever that means. With hashtag. Timelessness. Okay, so what did that? How would I summarize that? Whatever that is, with giant spaces in between it, that required me to hit the show more button. What am I supposed to glean from this? A picture of Echinacea, I guess. Shit. Emoticon guy. Okay. We're me weed. It's supposed to inspire some sort of, oh yeah, I so much want to pay attention to wear me weed. Some dopey pothead. 1905. Do you have photographic memory? I can't even imagine why he thinks I would have a photographic memory, but whatever. I have a memory. It sort of looks like photographs sometimes, but yeah, when I really look at the photographs, it's kind of just chunky. There's some bits that are pretty clear, but some of the photographs have weird new shit in it that you're saying, where did the hell that come from? There wasn't any blue trees when I took the photograph. Yeah. Well, anyway, don't want to get into a whole bunch of brain science. Whoa, look at this big pile of crap. All right. It's not really big brain. So far you're doing is outlining that force itself is a force of nature which permeates everything, gives animation to the universe. Yeah, I'm saying there's a force that has to come from the outside because it's a push universe, because pull is silly. There is no pull. Pulls are always just inverted pushes. That seems to be one of those facts that somehow all the smart people are missing. Alright, what he's referring to, I don't even know who you're talking to. What he's referring to as force bits is just a concept of energy. Again, obviously, it's the thing, you can't make it any clearer. The force bits are moving the speed of light. They interact with the matter bits and make them move slower than the speed of light. So there's heavy things that move slow, and there's fast things that move fast. And all the fast things move one speed. And that's why there's quantum mechanics, because the fast stuff is in little pieces of fast stuff. And it can only add one little fast bit at a time. And it has to be a whole fast bit, because the fast bits are all going one fastness, the speed of light. They all have one unit of momentum. So the one unit, the Planck unit of momentum, is what's controlling the universe. Yes. I would call his... So this is... I guess he's responding to somebody else somehow. Somehow this was a response comment? I don't know. I would call his half complete. Well, you can call it anything you want. I'm saying it's 9,000,000% more complete than any rubbish you're going to give me. What's your more complete theory? Let's see it, because I'll point out how pathetically incomplete it is. But anyway, because time is also a factor. A factor in what? Time is the speed of light. There is no other time. Nothing else is changing time. It takes time to go the speed of light, to cover distance. A photon, energy in the universe, takes time to get from point A to point B, and it's a consistent amount of time it takes to get from point A to point B, because it travels in straight lines, whether you like it or not. But that's how it really works. It travels in dead straight lines. And the real universe is photons, all in exact positions at any one moment in time. They're all in some place, heading someplace. And if I froze the universe, that's what you would see, is a bunch of little spots, little dots in the universe. Okay, and each one of them has a little arrow pointing in the direction it's going at the speed of light. And that's it. There is no other anything. There's 3 physical directions, okay, that the thing can move in. Okay? It can move in any one of the directions in the 3-dimensional universe, and it does it at a speed. And that's it. That's the universe, whackhead. Alright? There's no time place. Fuck. Anyway. Because time is also a factor. And if you're into physics, so you think that's being into physics, is to make up woolly stories about dimensions that don't have any, that have no rational connection to reality. There's absolutely zero evidence that you can create anything called a fourth dimension. Anyway, you realize time itself can be warped. No, if you're into physics, you realize time itself can be warped. So he says this. So if you're into physics, you buy a completely extraordinary claim based on pretty much no evidence. I mean, pretty much zero evidence. I mean, GPS is evidence that clocks break. It's not evidence that time breaks or time changes at all. That somehow photons don't move the speed of light. There's absolutely no evidence of that. Anyway, making it its own force of nature. Making it its own force of nature. And force of nature how? In the fact that somehow you're saying because you're in some sort of frame, two things can be in different frames and they can sit there and say the facts changed because I'm in a different position than you and I'm looking at something from a different position and I see things differently. Okay, like an explosion happened at the same time, right? Two simultaneously events, two explosions. And because you're here and I'm here, we're going to have some silly, stupid, and ignorant argument about which explosion happened first based on when we saw it, when we know seeing requires time to see. So we're going to sit there and actually be stupid enough to fall for the idea that these two events are two factually different things. Like the two events didn't happen at the same time. No, because you see it different and he sees it different, that somehow that means it is in fact different. No, it's not different. It is a fact. And if you understand that a force takes time to get somewhere and bounce off of something and then get back to you, then you understand that no, time didn't change. My ability to see it changed. My ability to see something doesn't have anything to do with what it is. Oh, God. Anyway. Making it own force of nature and inevitably part of the concept of energy. So just more horse shit. It's obviously energy. Energy is motion. The little force bits are moving a lot. And if the same amount of them hit me from this side, if there's 10 elephants on one side of me hitting me and 10 elephants on the other side, then I don't go anywhere. But if there's 11 elephants on this side, right, all hitting with the same weight and pressure, well then I'm going to move in the direction of the 11 elephants. And so my movement's not going to be much, it's just going to be one elephant more. So I'm not going to move 11 elephants worth, I'm just going to move that one extra elephant's worth. Because that's the only part over balance. So every time we say there's energy in the universe, we're only seeing the imbalance part. We're not seeing all the energy. We're just seeing the part that's out of balance. Crap. Part of the concept of energy would be accurate to break it down to a large series of force bits exclusively. Wouldn't be accurate. It wouldn't. He's saying it somehow wouldn't be accurate to say the force is what moves things. So he's saying Newton's wrong, okay, that things don't have to be acted on by a force to stop moving or to change, that force doesn't force things to move, and that things are stopped or bent in their movement by another force interacting. You don't need a force to force something to happen. You don't need a cause. You can just have effect. Yeah, right. You're an idiot. Anyway, break it down to a large series of force bits exclusively. Yes, that's all you need. All you need is the fact that there's two kinds of force, and two kinds of matter, electron, proton. Two kinds of force, proton force, electron force. They behave inversely. That explains the magnets. That explains charge. And there's only two kinds of interaction. Head-on collisions with reflections and head-on collisions with, oops, they did that. So that's it. Two kinds of interaction. This and this. And that's all you need. to create everything we see in the universe. Okay. It also weird. I don't know whether he's foreign or something. What you reduce material reality to only two physical entities, protons and electrons. Yes, they're the only things that really do anything. All the rest of your little magical anti-this and wooey and all the other crap has absolutely no role to play in chemistry or physics or biology or anything. Okay, neutrinos are not making your liver work. Bosons, no, not really, not a factor. Oh, God, people are so stupid. Quarks, you really think your kidneys need quarks? No, they don't need quarks. Okay, only two physical entities. But yet also neglects to mention neutrons. Well, neutrons are made of an electron and a proton. See? A neutron is just another form of electron and proton. And they call it a neutron because it's a dipole, a very small dipole. And from a distance, you can't tell it's a dipole, because the two poles are so close to each other. So basically, a dipole is saying to everything around it, right? Technically, a dipole would be saying, come to me and go away from me in equal proportions. And so, of course, something seeing it from a distance would say, that's just nothing. I mean, it's saying come to me just as much as it's saying stay the fuck away from me. So it's a nothing, and that's why you call it neutral. But it's not neutral. Cripes. Neutrons in the first paragraph. Right, that first paragraph of what I'm wondering. I obviously mentioned neutrons plenty, but the point is neutrons are just electron and proton, very close together. When a neutron and an electron are very far apart, well, a proton and an electron. When a proton and an electron are close together, they're a neutron. When they're very far apart, they're a hydrogen atom. That's why hydrogen atoms float. Anyway, I'm guessing. Not to mention neutrons in the first paragraph. I'm guessing he denies the Higgs field too. Why wouldn't I deny something that doesn't mean anything? You really think that their silly model of their little fake triangles where they predicted that, there's certain energy humps, in reality. That it's almost like saying, look, you can imagine that you could say there's a limit to how big a star could be. Okay, there's a physical limit because the gravity gets too intense and all the matter breaks down and it blows up. So you could say, okay, that's why there's no big giant stars in the universe, right? And you could say, then it goes to the next level, where then the stars that are now fixed in size, they can't get megastars, so they can only be certain size. And then you could make the argument, well, what's the next paradigm? Well, the next paradigm is that the stars would end up being attracted to each other and get stuck in orbits, and then you create something called a galaxy. The solar system in between, but that's such a minor part of the universe that it's not even worth discussing. So you can understand there would be levels, okay? Just like with a human being, we're not really living things, right? The cells we're made of are the first living thing. That's what you call a living thing, a cell. And we're like cities of living things. We're like a whole different kind of life form. We're not a cell, we're a whole giant colony of cells. We're like an ant colony of cells. And then you have the ant colony, which takes the little organisms that are really made out of cells, and then the cells are made into a robot, and then the whole bunch of robots are all programmed to make a colony. See, those are the levels. The Higgs boson is just recognizing that there's these plateaus of complexity, and there's plateaus of force. And so all they predicted really was, well, if we make this stuff move faster, we're going to make another level, okay, of interaction. We're going to smash the pieces a little bit smaller. So it's just changing the speed on a blender almost. And it's just predicting, well, how small will the bits get if I press number 2? Well, how small will they get if I press number 3? So the Higgs boson was just saying, oh yeah, I'll have the same effect. I'll make smaller particles if I hit number 3. And that's the Higgs boson. It's just bullshit. And again, you believe it. Why? Because you understand the data that they're basing the conclusion on. You understand why it has to be a Higgs boson. I mean, it exists for a trillionth of a second as a particle they never see. So this is what they see. Right. Let's go back to what they really see. The actual thing they see is 1 million of these little cloud chamber images. So you have an image where you have little traces, and the traces are little straight lines, or there's straight lines, and then there's another line that comes off this way and a line that comes off that way, or there's a line where it starts to go really slow and it just curls up into nothing. Right, so this is what they see, and so they have a pattern that does one of these here, and then over here this one goes here. Okay, and then they have a third thing that's going here, and there's empty space between them. And what they're saying is, oh, what causes this is that a Higgs boson hit here, or we'll say a gluon, a gluon hit here. Okay, so a gluon was actually here, but it was invisible. We couldn't see it because it wasn't charged, and so that's what gave this momentum. But it gave it momentum, see, based on this angle, so we know that something else had to go this way. Oh, okay, and so that was the Higgs boson, you see, because it went over here and it made this do this, and the byproduct of that was it shot a little bit going over here, and that shot another bit going over here. So that's all they're doing, okay? And they're just making these pieces up. This stuff isn't actual stuff. They're just making up a story about what went over here. Okay, and they're just going based on its speed. The faster it goes, they make assumptions about what's possible. But it's just electrons and protons. That's what each one of these things is. It's just an electron going really, really, really fast. Okay, that might be what you call a Higgs boson, a really, really fast electron. And a really fast electron would just be an electron that has a big ray of force chasing after it. So a long ray. Instead of a regular ray of light, it's a really long ray of light. And that really long ray of energy is right behind this boson thing, the electron. And so the electron goes faster and faster and faster. And as it goes faster and faster, it takes longer and longer for all these little bits to catch up and to go through the electron. That is, give the electron energy and reflect. So it takes a much longer time. So if I have something rolling really fast and I throw a bunch of little things after it, moving a little bit faster, they'll finally catch up to it, and then each one of them will bang into it and make it go a little bit faster and a little faster and a little faster. So when they see an electron do something bizarre that isn't very electron-like, it's really because it's not an electron. It's an electron with a whole bunch of force right behind it. But anyway, believe what you wish, and again, just be so obnoxiously patronizing to say, we have proven it. Oh, it's so obvious. Don't you believe in this obvious Higgs boson? There's nothing obvious about it at all. There's no good theory of it. There's just a made-up story. And you're buying it, and then you're sitting there saying, I trust the storytellers. That's all you're saying to me. You trust the storytellers. Because you don't have any knowledge of that yourself. Anyway, it doesn't seem as though you took the results of the double slit test into account for this. Amazing. I have just shown more double slit experiments. I've watched more double slit experiments. I've done more analysis of double slit experiments than anyone on YouTube. Anyone. There's no one who's covered the subject with as many hours of content that I have. You fucking idiot. Frankly, Jesus, what an amazing pile of shit. All right, I think that might end up rocking his world. No, you're the one who has a silly delusion, a pile of misinformation, a bunch of their lies in your head about detector experiments and all the other woo. So you're the one. Go to my subject videos if you have any integrity at all, you fucking patronizing douche. And answer the questions I ask in those videos. Why don't you explain why the pattern doesn't match the math in visible photons? Why don't you explain how randomness can project images in the multi-slit experiment? Why don't you explain why the math works when you change what you're measuring, the thickness of the impediment in the double slit experiment and the width of the slit in the single slit? Why does the math work when those two variables are fundamentally different? Oh, because the real distance is the distance between the surfaces. It's a surface phenomenon, idiot. Quite obviously. Anyway, with two types of force and two types of matter, all you need is two types of interaction to exploit all that is seen in the complex universe. Two forces, AB, and two types of matter, AB, can have several more than two types of interactions. They don't need to, idiot. That's the point. They only need two. All right? That's all they need. There's no requirement to do everything you can possibly do. I'm not required to be, as a living thing, to do everything I could possibly ever do. That would be, well, I guess in the multiverse theory, you end up doing everything you could possibly do. But there's no need to. All right, several more than two types of interaction. So again, the two types are based, again, just to illustrate. So I don't know what his other type of interaction would be, in the sense that, there's two basic orientations something can happen at. Okay, two things can hit this way. One reflects and one goes this way. Now, if they're the same color, nothing. You can't tell the difference between missing and hitting. You get exactly the same universe back out. But if they're a different color or a different type, so we just make this a dotted line, right? Then the dotted line ends up going this way, so the universe changes, right? You can see that. The universe changes if there are two types, right? And the other interaction would be two things hit each other, and they go this way and this way. Now, again, if they're the same color this way or that way, you wouldn't know the difference. But if there's a rule, like a right-hand rule or something similar, then you could understand, okay, that the force goes one way and the momentum of the object goes the other way, in the sense that this would be the inside of the electron and this would be the force. Well, I won't put a circle around the force, that would be deceptive. So you can sort of understand the force will do one thing, the body will do the opposite thing, the inverse thing. And frankly, that's all you need to do is move the pressure. So if you're applying pressure this way and the pressure leaves this way or this way, you can sort of understand that's going to be a very different reaction than if you apply pressure and the pressure ends up going this way when you hit something. Those are two different, fundamentally different outcomes. But that's all you need. Anyway, I don't think he really considered the possibility, so here he goes again. I mean, there's just, again, you can pretend that those possibilities can mean something, but they can't. Some of the possibilities don't mean anything. When A hits A and A does different things, the outcomes are always going to be the same. And you're not going to be able to tell hitting from missing. I mean, I just illustrated it, right? So he's playing a math game where he's not accounting for the fact that you're not going to be able to see the difference. Again, how many times do I have to go over this subject? You won't see the difference. If I say those two things went through each other, what's the outcome? Well, the outcome is an arrow going this way and an arrow going that way. If I say those two things missed each other, what's the outcome? Well, there's a thing going this way and there's a thing going that way. If I say those two things reflected off each other, what's the outcome? Well, there's a thing going this way and a thing going this way. Every single possibility ends up with the same outcome. The outcome is the same fucking universe. Nothing fucking goddamn changes, retard. So why would I consider possibilities that don't add up to anything called a visible consequence? There's nothing there. There's no effect. There's a cause, no effect, because you can't tell it from all the other causes. So it's only specific circumstances where A hits B in the first place where you can have a different outcome. I'm counting 6 so far. So he's playing, again, this is just illustrates how lost in their bullshit these people are. Okay, don't account for the reality. Don't pay any attention to the real argument. Argue semantical math. Okay, that's completely denying a fundamental fact of the physics outlined in the sense that A and B are fundamentally different. And all the A's are fundamentally the same, and all the B's are fundamentally the same. Anyway. 4, if you rule out force interacting with two forms of matter and assume they aren't pieces of matter smaller than electrons and protons. No, there's no other piece of matter, retard. I already stated it pretty clearly. Shows an ignorance of modern physics. So again, there's no ignorance of any physics here. You're the one pretending I'm going to change the outline to circumstance, and because you're an asshole, frankly. Anyway. All right. I mean, just what a pathetically petty counter argument. And assume there aren't pieces of smaller matter that... Okay, we already did that. They found plenty of subatomic particles through particle colliders. Says you. Show me a picture of one of them. What's your picture of a positron? A positron is... all they have is a picture of a positron, right? Okay. Is a notion. So it's all just based on their presumptions about what electrons and protons even are. So a positron was found because you have a piece of lead and you shoot radioactive bits, beta particles, I guess they are, protons anyway, through the lead. And they have an assumption about how fast these protons can possibly go. And so what they see is that something travels through the medium and it curls this way instead of curling this way. And their assumption is they think, okay, that the motor force, for example, is something that happens to individual electrons and individual protons will somehow be moving in a direction, and you'll apply a field across them because they think the north end shoots stuff out and the south end collects it, and they think this is a field circling, and that you'll have motion in this direction, in the third dimension, so that you have 3 dimensions, right? So their argument is I shoot the current going this way, and I apply the magnetic field this way, and the force ends up shooting the thing out this way. They think little electrons and protons can do that. Well, anyway, these trails are being drawn by creating ions that are creating photons. They're hitting actual ions. All right, so it's the path of the ions that they're seeing, really, is what ions did I hit with the energy. So they're not seeing an actual particle doing something. They're seeing what's happening to ions, okay, as they hit them, as they hit atoms. What happens to the atoms as they hit atoms? All right, so they're seeing what happens to moving atoms. They're not seeing what happens to a moving electron. All right, and the other argument is they think the speed of this thing that comes in here is the wrong speed. It can't be a proton because it's moving too fast. So it's moving like it was an electron. And so again, that's all they have as a theory. They don't have anything else. So first, they haven't explained what exactly happened when it went through the lead. Like there's this expectation somehow the proton made it all the way through the lead without hitting anything. And so that this thing coming out has to still be a proton or still has to be an electron, when it could in fact be an ion. So there's no hard evidence for any of this stuff. So they just invented this positron because it did this instead of doing that. So electrons do this, okay, they say, okay, and protons do this, all right, and this is going too fast to be a proton, and that's the only reason why. So it could be a proton. It's just that they claim, no, protons can't do this. Protons can't go this fast and they can't go through. But what if they can? Oh, okay, then yeah, it could be a proton going fast. So anyway, that's all they got. There's no picture of a positron, and then there's no explanation whatsoever of what this positron would be doing in the universe. Where are all the positrons? Where are they? What are they doing inside of atoms right now? What are the positrons fucking doing? Can you make any sense out of it? Where in your model do they fit? Where do they fit? Okay, here we have a model of an atom, even with your silly clouds, right? You have your stupid clouds of electron because you don't even think things are in actual places. So you have some stupid morphic cloud. Where are the positrons? Oh, it is pathetic. All right. Through particle colliders. He should have called his daft physics. Wow. And he LOL'd that, right? Like no one's already done that. So all I have to do is make fun of your name. That's it. That's all I have to do, right? To win. Your name is Gustabevev 99.9. You're not even a whole thing. You got like some kind of pieces hanging off of you. 49.9. I mean, what is that? How many times your mother slept with somebody for money? LOL. Oh, God, you people are so fucking pathetic. Could you grow some kind of penis? I mean, you have any nuts at all? I mean, how can you be such a fucking goddamn weak-ass piece of shit to type this crap? Like you have a right, okay, to assume and presume. You haven't done any research. You didn't make a single counter argument here that makes any sense. You didn't really deal with any of the statements as stated. You just presumed that they're saying something they're not saying. All right, anyway. And that's aside from the fact that there are actually 4 fundamental forces in nature, not 2. And I've already explained the other fundamental forces. So again, this is just so fucking lame. Right? So they say there's something called a strong force, the magical strong force. So they have virtual photon, bent space, right? And then the 2 other forces, which are kind of like strong and weak, which are kind of, well, you have the magnetic force, which is really only one force, right? I mean, charge is one thing, not 2 things. I mean, obviously, you know, that's why it can do attraction and repulsion. Is because of the inverse relationship. Oh, I already pointed out in 2 plus 2 plus 2 physics. So the point he was making, the strong force. So if you just do this simple little perpendicular thing I just showed you, right? And you have an electron that would be tied to a neutron, right? So this is, a proton. So here's the neutron. Proton and electron. And then all I have to do is add another proton over here. Okay, and what's going to happen? Well, by this 2 kinds of interaction theory, any white force will end up going out of this blue thing, and any white force here will end up going out of this blue thing. So if 2 protons were sitting here by themselves, then any white force between them would keep reflecting, and the closer they got, the more reflections at the speed of light. And so they'd be pushed apart, dramatically pushed apart. All right, but if there's an electron between them, then all the blue force leaks out of the electron, and if there's all the white force, and then all the blue force would end up leaking out of the protons. And so all the opposite forces do the perpendicular thing. That is, when a blue hits a white, the action is this. The momentum goes one way and the force goes the other way. The reflection is perpendicular. And if white hits white, it's just a reflection. The electron gets a unit of motion this way, loses a unit going this way, which is a 2x increase, and the force just reflects. That's it. So those are your 2 interactions, and if you apply those 2 interactions, you can explain why protons can get close to protons. 2 protons can get really close to each other if there's an electron in the middle. So the strong force, you see, they think you need a really strong force to push these protons together. You don't need any strong force. It's the absence of force. It's the fact that the force has been dissipated that the protons can get close to each other. Perfectly viable explanation. But you couldn't give a shit about being a fair cop because you're just a slandering, lazy shit mouth. Yeah, fuck you. All right. Four fundamental forces of nature, not two. So I've never asserted that there's only two fundamental forces in nature. What I've asserted is that there's really just magnetism. There's charge. Charge creates magnetic monopoles. Electricity is just something that happens in wires. That's an atomic function. That's chemistry. So there's no electric field. There's just magnetism. That's a consequence of charged dipoles. So you take charge, you make a dipole, you have magnetism, and atoms are held together by magnetic forces, and it's the magnetic forces that allow protons to get really close to each other. All right. Good enough. Great work. Fight the good fight. Yes, well, it seems little purpose, but I will, because there's nothing else to do on this shithole of a stupid-ass moron planet. But spit on the garbage whenever you can. Anyway, what do you think of Glenn Borkert's? What a jeez. That's the De Hilster hero. Okay, De Hilster thinks it's somehow brilliant. Ether bullshit. So it is kind of funny. He keeps promoting an etherist when he's not an etherist, just because he loves this infinity nonsense. Infinity and beyond. Okay, non-mechanical. Why would I be interested in any kind of non-mechanical theory? Infinite universe, unified cycle theory. Well, what? Cycles how? How does it cycle? How does somebody cycle in any kind of unified way? It involves ether. Rejects Big Bang, postulates that the universe is infinite in extent. It's just a silly postulate to make because you're never going to have the evidence to make the postulate. So it's just why even opine on the on such a question when there's nowhere to glean any evidence from. The universe can cycle as a Big Bang. It could cycle as a. I mean, I don't believe in Big Bang. I believe in, strong gravity, weak gravity, strong gravity, weak gravity. I mean, as stuff consolidates, there's less force out in the universe because the force is trapped in the atoms. And then as you collect all the force from the outside, the push force, then the pushing out force inside the atoms gets stronger because there's less pushing in, so the atoms start to expand. And then as they expand, they release energy. As they release energy to the field, then it contracts again because there's more pressure on the outside than the inside. And it's just a balance between the outside and the inside. Galaxies go this size, and then they go this size, and then they go this size, and then they go this size. All right. And the universe is infinite extent, external, and no origin or beginning, whatever. Doesn't matter to me. But I'm just saying, how could people realistically? There's just so little evidence. You can't really do this crap. I mean, the only indication, we have some indications, right? The things far away do appear to be brighter and smaller. So that tells you something, that the universe isn't steady state. That it at least goes through changes. It was a different place 13 billion light years ago. Right? Anyway, rejects multiverses and time as a fourth dimension. Yes, those are all good things to reject, but again, if you're replacing them with more wooey nonsense, what's the point almost? But yes, I'm all for somebody making rational arguments about how conventional physics is unevidenced and silly. So good, do that. But his counter theory is wooey, magical, and mushy. All right, and rejects the woo of quantum mechanics and replaces it with the woo of circular theory, unified circle theory. I'm sure he has a bunch of swirling tornadoes and hyperborealoids and all kinds of horse shit running the universe. Books where it explains include Universal Cycle Theory. Wow, it just rolls right off the tongue. The Scientific Worldview and 10 Assumptions of Science and Infinite Universe Theory. Yeah, sorry. His blog spot is kind of like archaic internet. Unfortunately, has anthropogenic climate change skeptic. He is an well, then he's a real idiot, right? Um, I'll just make the, I've made it 4 million times, but I mean, the carbon thing isn't that hard to understand. So even though carbon is a very minor, carbon dioxide, greenhouse gas, and that it only accounts for a small percentage of the thermal locking, okay, that takes place. Water in the atmosphere is, 97% of greenhouse gas is just water vapor. And then you have this little 3% that carbon dioxide adds. Okay. But even though that's true, increasing that 3%, increases how much water ends up here. So the more heat you create, the more water you create in the atmosphere. So the hotter the surface gets, the more water vapor that will be put in, that the atmosphere can hold. Okay. So the more energetic the water is on the surface, the more of it pops up here. Okay, so the hotter you make it, that's why deserts are deserts. It's because it's hot, and the water goes right into the atmosphere. Okay, so obviously any increase in temperature, okay, creates an increase in water, which creates an increase in temperature. So that's the chain reaction you got to avoid, right? I mean, neutrons are just one little simple little thing, no big deal. But you shoot a neutron into a bunch of uranium, and you end up with getting 3 more neutrons back out, and then you end up with a whole chain reaction, and you go blow everything up. So you have to understand what chain reactions are. And carbon dioxide is a trigger substance. And now, the other argument is so simple, right? I mean, so you have this Jurassic period where there's a bunch of dead stuff living. Well, even before that. And all this living stuff, okay, is dying, and it buries itself, and it buries itself kind of well in the sense that it puts a bunch of carbon into the ground. Okay, a bunch of layers of carbon, layers and layers and layers of carbon. It has to get the carbon from CO2, the carbon dioxide in the atmosphere. So it pulls CO2 out of the atmosphere, and it puts it into the ground. All right, now, so it's in the ground in the form of all kinds of peat and methane gas and all kinds of different things, different forms of that carbon have been fossilized and put in the ground. Now, as it was doing that, the Earth was really hot back then when there was a whole bunch of this CO2, right? The Earth got really hot because a lot of water was in the environment, so in the atmosphere. So it was really humid. Okay, so that's why everything was swampy, and that's why all our ancient relatives are little swamp dwellers and shit. Everything was a swamp dweller. This whole world was a fucking swamp. That. So the point is that the dinosaurs and all this stuff went extinct. Well, they probably were going extinct anyway because there was a consequence. They kept doing this. They kept taking CO2 from the air and putting it into the ground. So they're putting all this carbon into the goddamn ground, and we see it. Okay, we're using it right now. A zillion tons of this really powerful oil, okay, that's in the ground, and coal. I mean, a million bazillion light years of energy in coal in the ground. So for millions of years, living things were burying their dead, so to speak, and taking them out of the life cycle, okay, the circle of life. They took them out of the circle of life. All this carbon got out of the circle of life. And everybody knows it's there. It's not magic. So there's a ton of oil, except like maybe this berserker guy, whatever, Borchert, maybe he believes oil is made by the earth or some kind of wacky shit. Anyway, it doesn't matter. It's carbon. It's all just carbon. Black crap. Black crap, black crap, black crap everywhere in the ground. And now what are we doing? So the dinosaurs were doomed because the dinosaurs didn't do it, actually. The plants did it. But anyway, it's all the dead plants mostly. But anyway, so all this stuff keeps dying, keeps getting buried, just keeps getting buried. So it gets colder and colder and colder, right? Because you're taking one of the greenhouse gases and reducing it and taking it out of the atmosphere. And therefore, you're making it colder. And as it gets colder, less water, colder, blah, blah, blah. Chain reaction, dinosaurs doomed. Okay? Now, certainly something pushed them over the edge would be the meteor thing, making it even worse for a while. So, but clearly that's the cycle they're dependent on. And so now what have we done? Civilization has come along, and we took half of the oil, right? 1/2 of that zillion bazillion gallons over the last 100 years, and we put that carbon back out there, right? And then we're destroying the trees, which are planting the carbon back in the ground, right? We're killing the vegetation, so that's another negative in the sense that we don't have them putting it back in the ground again, so that's more carbon back in the atmosphere. And then we're burning the coal, and that's a big one. And as it gets warmer, it starts to defreeze all the methane, so now all this other carbon's getting back in, right? So now you're increasing the carbon dioxide, you're returning us back in time to when the percentage of carbon dioxide was higher, maybe 4 or 6 or 8%. And now we're going backward in time. The planet gets hot, right? Because we're putting all of this it's stored heat capacity. It's stored windows. We're putting the windows back into the frame of the house, and now the house is going to get hot. That's just too obvious. Can anybody rationally not see the correlation there has to be between us taking all of these corpses and throwing them back into the carbon cycle and say, that doesn't change anything? That wasn't a meaningful event in history. The fact that all this carbon got pulled into the ground, that wasn't a meaningful event. That didn't do anything. That didn't change anything. Are you really that fucking stupid? But there probably is just, people are that fucking, they want to believe. They want to believe God made it all okay. God says we can burn all the oil. God says we can burn all the coal. Doesn't matter. Can't hurt anything. Stupid bastards. All right. So, enough of that. Yeah, I got no use for Borkert, frankly. It's just another tinfoil hat nut. And like I said, the Bill Gates guy makes some good arguments about the bullshit of conventional physics. All of them make some good arguments about the bullshit of conventional physics. But then they start talking their shit and the game's over because their shit is even wackier. Swirly bullshit. Wooey forces. Alright, enough of a video. So, till the next time, and such, so forth and whatnot.